Ryan, and welcome back to yet another wacky physics video. Today we have this problem, and it starts us off with this box being loaded onto this car with this spring. Now this spring has a spring constant of 500 newtons per meter, and it's compressed 0.36 meters. And the question's asking at what speed do the boxes enter the truck bed, and then the second part asks that some sand is spilled in front, and it has some friction. And it's asking us, do the boxes still make it to the bed of the truck with that friction involved? So to solve the first part, and the problem wants us to use this equation, which is kinetic energy initial plus potential energy initial plus work external is equal to kinetic final plus potential final plus change in thermal. So with that, we start the problem. Part A, what do we know? We know that the crates have a mass of 2.5 kilograms. The springs have a spring constant of 500 newtons per meter and a compression of 0.36 meters. We have a height that we need to get to of 1.0 meters. And what we need to find is a velocity once it enters the truck bed. Equations we need to use / remember for this problem are the U spring, or the energy for a spring, the kinetic energy, potential energy, and the equation that was given to us above. The process. So to find the initial, or the left side, we need to find the initial. And the only thing that has energy initially in this setup is going to be spring, because the spring's being compressed. And since from our reference point, since the crate is on the ground, that's going to be our 0 in our y coordinate for the mgh. So there's no potential energy from gravity, and there's no kinetic energy because it's not moving. So the only thing here is the U spring, or the potential energy from the spring. And there's no work external because there's no friction, and the work acting on it from gravity is being accounted for from the potential. And to find the final, we need to figure out the kinetic energy, which is going to contain our answer, which is how fast it's going to be moving into the bed, and the potential energy. So it needs to go up 1 meter. That's going to take energy, and that kind of energy is from potential gravity energy, which is mgh, which is what we're going to solve for. So our equations will look like this. U spring, energy from the spring, is going to be equal to the kinetic energy plus the potential energy once it's gone up that 1 meter height. Plug in our variables, or expand this a bit, 1/2 the spring constant times the change in distance squared is equal to 1/2 mv squared plus mgh. We plug in our knowns. We know all of these except for v, and then we just solve for v, and we get that v is equal to 2.51 meters per second. And that's our answer for part A. Now we move on to part B. So for part B, it gives us friction right in front of the truck, right in front of the crate for 50 centimeters. And it's asking us, will it make it up to the top of that truck bed? So what we know the crate mass, we know the spring stuff, we know the height, but this time we have friction, and we know the friction constant, and we know the distance. And we need to figure out if the box will make it up the ramp. Now, the only thing we added to what we should know / remember for part B is this right here, the work equation, which is force times distance, where force is our force from the friction. And we can figure that out with the equation below, which is force of friction is equal to the friction coefficient times the normal force, where normal force is mass times gravity, right? Because the normal force is the force acting against gravity, stopping it from going through the ground. So we need a force pushing up on it. And the equation they gave us, except we're not going to be using the E thermal. I'll explain why. So the process. Kinetic energy initial, it's going to be 0, right? Because it's not moving still. Potential energy initial is still going to be, the gravity potential energy is still going to be 0 because our reference point starts right here where y is 0. And our spring, our U spring, is going to be the same as the last problem. Although this time we have an external work acting on it, and that's going to be the friction force that's acting against our movement, so it's going to be negative. And then we have our kinetic friction, our kinetic energy from the truck for the crate, and then our potential energy for it getting up here. So we set up our equation. It's 1/2 k times the change in distance squared, right? That's for our spring. And then this is our work right here. It's negative mass times gravity times the coefficient of friction. That's our force right there. Specifically, this is our normal force. This turns into our friction force. And then this turns it into our work with this distance right here, which is going to be 50 centimeters or 0.5 meters. So we set all of this equal to 1/2 mv squared plus mgh. I'm sorry, this is a typo. We plug in all our knowns, which happens to be all of these numbers except for v. And we solve. We don't necessarily solve, we can just simplify, right? Because we don't need to find any values. We just need to see if it can get up there. And you'll see how we can see that in a second. So we plug in all these numbers, we get 32.4 joules minus 4.9. That's the work done by friction, the external work done by friction. It has to be greater than the kinetic energy and the potential energy, which it is. And because of that, because the energy we start off with is greater than the energy that we need to get up there, after the fact that we subtracted that external work from the friction, that means that this crate has enough energy to reach the top of this crate going at a certain velocity. And we could figure that out, solve for it, but that doesn't necessarily pertain to the scope of this problem, but you could easily solve for it by just plugging in for V. And yeah, that's about it for this problem. This is a kind of a long video, I understand, but this is a lot going on in this problem. So if you got what happened and you liked the video, make sure to like, favorite, and subscribe, and I will see you in the next Wacky Physics video. Thank you.